Hey, Brian.
Hi, how's it going?
Good. How about you?
Doing well. Cool. Is the screen share working? Is the screen share working properly?
Yep. Looks
Cool.
good.
Awesome.
Good looking theme.
Thank you. Can't go wrong with a dark gray background.
Dark gray, yeah.
Yeah, works well.
So we'll just give it a couple more minutes, let people pour in, and then we'll get started.
Cool. Sounds good.
Okay, I think we should get started. So, hi everyone, welcome to the ILLIXR Consortium open meeting. Today we have Bryan Chris Brown from Project North Star. Bryan has been working on Project North Star since 2018 and has helped with the development efforts at multiple layers of the software stack, including Steam VR, integration, optical calibration systems, and Unity and Unreal integrations. He graduated from Morgan State University in 2017 with a degree in architecture. So quite a pivot from architecture to computer science and XR, and worked in architectural visualization and rendering for 5 years before joining Looking Glass Factory in March of 2021. We have been working with Bryan for, I guess, over a year now. It's, running ILLIXR on the open source North Star headset. It's been quite fun so far. And I guess today we'll find out more about what is next for Project North Star. To you, Bryan.
Yeah, thanks for the intro. Appreciate it. So yeah, my talk today is largely structured around sort of our next steps for the North Star headset. And we'll sort of go through that in the next slides. So we already sort of went over the background, so I'll skip this a little bit. So brief intro to what is Project North Star. So Project North Star is an open source augmented reality headset that was started by Leap Motion, who is now Ultraleap, in 2018. The goal of the headset is to provide a high resolution, wide field of view experience that's also 3D printable. And you can essentially configure it, build it yourself, and you completely own the headsets. There's no one tracking you or anything like that. We currently have support for both Windows, Linux, operating systems, and have integrations with Unreal Engine, Unity, and StereoKit, of course. And then here's a little video of a through the lens footage of North Star. So you can see it's pretty high quality, very fun to work with. Moving on from that, we're primarily an open source community, so it's less directly involved with Ultraleap at the moment, and is largely supported by folks like myself who sort of joined and have just carried on the torch since then. So we've got a Discord currently of around 2,500 users, all interested in 3D printing, building their own headsets, making variations and such like that. And the photos you can see here were taken by Matthew Dater, who accompanied us to the MIT Reality Hack in 2020, which is super fun. So it was really, really awesome to be able to demo the headset next to things like the HoloLens and Magic Leap. Skip too many slides. So why do we need to design a SLAM sensor anyways, right? We've got a headset, it works. We've got hand tracking from Ultraleap, and we've got optics, so you can actually see through, like you saw in that video. So what's the point of this, right? And up until now, we had been using off-the-shelf sensors, including the Z Mini, Intel RealSense, XVisio, and Structure Core. All of them have minor problems, sort of stemming from the fact that they're black box solutions, so we can't really control anything, especially with the RealSense. It was really plug it in, you get posed out of it because it was all done on device itself, on the Myriad controller. That was essentially a neural chip inside of the camera itself. So, we had no control over anything there. In fact, one of the problems we had with the sensor is that it would randomly disconnect from USB, which we couldn't fix. So we had to add buttons to the headset to reboot it every time it disconnected. So obviously that's not ideal, but it did work really well and we were having a lot of fun with it. And it was a really easy way to get developers on board with this full 6 degree of freedom headset. The issue now is that those sensors are now discontinued. So we have to come up with a solution for actually adding SLAM back into the headset. And we figured, instead of relying on yet another black box solution, we'll go ahead and design our own, which is really exciting. So it's one step closer to having a fully open source headset. So the partner we're working with on this is a company called ILLIXR. They've been making stereo cameras for quite a while and have built an open source API called Depth AI. And what this allows you to do is essentially run a myriad of algorithms directly on board the camera, similar to the RealSense, except this time we have control over it. So we can actually program what we want to run, whether that be stereo matching algorithms for actual stereo depth or tracking algorithms. We can do object recognition, and a myriad of other things. What's really exciting about this is that their hardware platform is largely open source. So ILLIXR make their business model by having essentially a translation layer that communicates directly to the Myriad X chip It makes that development process easier. And essentially all of the PCBs and everything on top of that are all open source, which is really exciting for us. Since it allows us to essentially have the most open source platform possible while still maintaining ease of use for the developer experience. Something we're generally against is having to have folks rebuild the wheel from scratch. So, you know, building an AR headset yourself with 3D printing is already hard enough. So we don't want to add in extra steps to make that more difficult for folks. So there's a few technical decisions with the SLAM system that we have to figure out. The things we've decided so far is that we're using global shutter cameras instead of rolling shutter. This is important since rolling shutter can have distortions, especially when you're moving fast. We're using wide field of view cameras to make sure we're getting the most data of the room or environment the user is in every frame. And then we're also using high frame rate cameras in addition to a high data rate IMU, or inertial measurement unit. This is important because while current SLAM systems typically use camera data around 30 frames per second or so, and then supplant it with the inertial measurement unit, we're seeing more papers come out from folks like ETH Zurich, where they're using event cameras, which are ultra high frame rate, really specialized cameras, which I won't get into in this talk, but they're very fun. So essentially we want to keep the doors open for being able to use high data rates from the camera systems themselves, in addition to the IMU in the future. Things we have yet to decide are what exactly are these cameras going to fit into the headset, right? How are they going to be configured? What angles are they going to be at? How much stereo overlap are they going to need? And what cost saving measures can we take? So because Northstar is an open source headset, we ideally want to keep the cost reasonable so folks can actually experiment with AR and build it themselves. Right now, generally speaking, the XR space is pretty at a cost disadvantage for folks who just want to get started and build something. In fact, that was sort of my original journey with Northstar. Here, I'll show off in my camera feed. My original Northstar headset was actually a Samsung Odyssey headset that I disassembled, and I bought it off of eBay for $150, mostly because I wanted to build a headset for cheaper than Magic Leap's prescription insert. This didn't end up working at the end of the day because I couldn't override Windows drivers, but is a fun little memento that I keep around. So generally, we want to keep this thing low cost. And what that means is trying to keep Northstar itself around $600 with all the sensors included, which is actually quite challenging. And we'll get into that in the next slide as well. So one of the things to look at is what are other projects doing? So the Oculus Quest is using 4 separate cameras, all angled further apart for each other for 2 reasons. One is to gather the essentially to have the widest range for controller tracking, since that's super important for their mission of having gaming, which is their primary business case. And then in addition, it allows them to not have occlusion problems. So with the cameras being all angled further apart, each camera being occluded at the same time is very unlikely. There's also headsets like the HTC Vive Focus, which have 6 different cameras on them, all used for different purposes, including SLAM, hand tracking, AR pass-through, and everything. You can see in that, that's the second photo on the page. The blue headset has cameras pointing in every which direction. Really just to maximize some of the same points I just made about the Quest, right? You want to make sure that your cameras aren't occluded at the same time, because that will cause issues with being able to intercept a frame and then have tracking points that persist through time. And of course, for hand tracking, there's the Ultraleap sensor, which uses just 2 cameras and IR illuminators to essentially track your hands with stereo depth. So the stereo disparity between those 2 cameras are incredibly important for that tracking system. So some experiments we've done so far is we've used a Luxona system called the 1090 FFC. I believe it's been renamed to something like the 2090 FFC, but essentially this is a myriad controller. So you can see the chip controller right here, which has FPC, or flexible printed circuit cables, to each one of the cameras, allowing you to mount them in pretty much whatever way you want, which is really exciting for us because we're doing a ton of little different experiments, as you can see. So we've got some of these set up where the cameras are super close together but angled out. We've got some of them that further apart, more like what they'll typically be on a headset. We were able to combine these with the existing sensors we're using. So you can see in the bottom of the page, we've got a Intel RealSense T261, a leap motion controller, and two of the wide FOV cameras on either side, and then a color sensor in the middle. So typically SLAM systems use monochrome data, not only to save costs, but also to be able to compute that data faster. And you can see an example of that in the GIF that's in the middle of the page there. So typically with our system, we've decided to use two monochrome OV9 282 sensors, and then one RGB sensor as well, which will allow us to do interesting things with room illumination and just sort of give us more data that we've been looking for that haven't had with our headset. And you can see one of the interesting things with the current implementation, which is an Intel RealSense and then Leap Motion controller, is that the cameras are actually very close together. So one of the interesting things moving forward, given that we're going to be using the stereo IR 170 sensor from Ultraleap, which is this tiny little rectangle here, I'll bring it a bit closer to the camera, is that these cameras here actually line up perfectly with the RealSense camera. So what I was talking about before with occlusion from the Oculus Quest camera positioning would essentially be really bad for us, because then both camera sets are actually getting the same amount of data. So one of the things we want to try and do is have the Ultraleap sensor get its own hand tracking data, and then have the ILLIXR system that we're building essentially have the most data from the room that's persistent as possible. That's as persistent as possible. So it comes into cost again, right? One of the things that's really interesting about North Star is that we're essentially a very small organization. We actually just got our nonprofit license a few weeks ago, which is really exciting for us. But we're not a for-profit company. We're not selling thousands and hundreds of thousands of these, and we don't have a very large advertising budget that we can use to subsidize our products. So when we're looking at a new sensor, we really have to take into account, okay, how much is this going to add to the overall cost of the headset? Especially with our goal of making North Star around a $600 headset, adding in $400 worth of cameras and AI systems definitely doesn't really fit the bill there. So with the RealSense, it was really nice because it was around $129 per sensor. And unfortunately, those are discontinued now. So we're sort of like, okay, can we even match that? Because the RealSense sensor was something that was manufactured manufactured with mass production in mind, right? So it was used by folks in robotics, folks in headsets, many different industries, right? So the user base is automatically larger than the one we have for North Star, which is a few thousand folks at the moment. Currently, the camera evaluation kit we're using here costs around $400, which is high, right? Definitely interferes with our pricing structure. However, it is using some pieces that are specifically for evaluation, like M12 lenses, so we can actually unscrew the lenses and screw in a different lens if we want to try a different field of view. And it also essentially, given that each part is bespoke and ordered in low volume, it's going to cost more. We ordered around 20 of those to send to contributors for North Star from around the world, which is really exciting. Things that will help us get the cost down for this will be things like economies of scale, crowdfunding, and essentially the opportunity to make a larger order. The moment you can order 1,000 pieces of a camera versus 12, things get much more manageable over time. And yeah, it would really help to have a large scale advertising network to subsidize things with. So I believe I missed a slide here. Let me just double check. Yeah, so this was the slide I missed here. So one of the things I didn't go over was why we're actually using a ILLIXR camera system. So this gives us some of the advantages of economy of scale, as ILLIXR are essentially selling cameras as a business model. So that means that they can essentially pass on some of the economy of scale savings they get to us. In addition, given that we're all developing for the same platform and same hardware generally, it allows, essentially allows us to leverage a larger community of open CV developers. And this is really important for us since North Star is still a niche, right? Like XR is still relatively small. Robotics is a much bigger industry. So being able to take advantage of some of the papers and SLAM tracking that's coming out of the robotics space, essentially immediately with these camera systems is really important. The folks at Luxonis actually also do have meetings with us, which is really exciting. It's been really difficult for us to have meetings with some of the larger companies like Qualcomm and others out there, just because we're not at the scale that those companies really need to succeed. When we are like, oh yeah, we have 2,500 Discord members, it's really exciting. They're like, oh, only 2,500. They're used to the volumes of like 200,000 or million or something like that. So definitely looking to grow the project, but it's been challenging to find partners that'll work with us in this way. So it's really exciting to have Luxonis on board with us. And Luxonis worked directly with folks at Argicam and other camera suppliers to essentially get access to camera sensors that we would only be able to get if we're ordering in bulk. So this allows us to essentially have really exciting access to sensors like LiDAR sensors or time of flight sensors that we wouldn't have access to otherwise. The really neat thing about this, the camera module I've been showing off as well, is that we can essentially just unplug the RGB camera. So if folks want to build a headset without that and just use the monochrome cameras on either side, they can do that really easily. Or if they want to use a time of flight sensor instead, they can actually just plug it in, which is really cool. So it definitely fits the notion of North Star being more modular and having more choice for the end user. And of course, this wouldn't really be possible without all of our contributors. So, it's not something I've been doing myself. It's impossible for one person to do alone, as I'm sure the folks from ILLIXR can attest to. So we have many contributors, just a few of the notable ones here who have really helped move the project forward. Some of the folks from Ultraleap and Leapmotion who really championed the project in the first place. And of course, folks from Collabora, ILLIXR, Luxonis, Ultraleap, and Simula VR have actually been incredibly helpful to us over the past years of the project existing. So at this point, I'm sort of going to leave it up here on this slide for a brief Q&A. So one of the things we haven't decided yet exactly is exactly how we're going to position these cameras, but also what kind of SLAM systems we're going to be using. So that's something we're still evaluating. And the folks at Monado have been doing some research in this area. The folks in ILLIXR have also been doing some research. For us, there are a few systems that look incredibly promising, including Spectacular AI, which is of course a closed source solution, but does have an open source implementation called HIB VIO, which is what you're seeing in that GIF in the middle there. In general, one of the things that would be really exciting for me is being able to actually properly benchmark these systems on the same camera systems. So one of the problems we have now is like, oh, there's a new SLAM paper out and it's all benchmarked on KDE or some large scale car tracking or self-learning, self-driving for cars. And obviously there's not a huge data set out there right now for SLAM in interior environments. So this is something that we're very excited in testing and hopeful that with the combined efforts of our essentially hardware system that we're trying to build out and folks at ILLIXR, Collabora, et cetera, will really be able to push this space forward and have a solution that not only will work for now, but can also be built on top of for the future. So.
Yeah, great. That's awesome. I have a lot of questions, and Bryan, first I want to apologize that I wasn't there to join Josefa for the introduction. I was having some machine issues, but obviously very excited to have you here, and thank you for joining. I think Javier from Intel has his hand up. I'll ask my questions after that. Javier, go ahead.
Hi, I'm just curious. So can you talk a little bit more about the SoC in which you guys are going to run the algorithms, or do you run the algorithms offline in a computer?
Yeah, so right now it's likely going to be both running them on a Myriad X inside of the Depth AI system, and then also in a compute onboard computer as well, which is right now we're looking at either an AMD based system with the RDNA2 graphics or the Intel Xe graphics. So we're still trying to decide which one will fit us best. And we're still benchmarking both those systems, which is super exciting. The leaps and bounds that mobile, essentially like small form factor computing has been able to make recently is very exciting, especially on the integrated graphics side of things. But yeah, ideally, right now, we've determined that it's going to be very difficult to take any SLAM system and run it directly on a Myriad X without a ton of resources. And given that we're a really small organization, the best thing for us would be running, using the Myriad X for things like feature detection, and then being able to take extra data from the camera systems and plug them into a onboard or by 86 compute system that's plugged into the headset.
Yeah, and I have a follow-up question about that. Actually, kind of linking with some of the recent activity I've seen in ILLIXR, because they just recently released, and probably Sarita can talk more about that, a plugin that allows you to do the VIO remotely. And I was just wondering if adding wireless capability to the headset could be something explored down the line.
Yeah, I think down the line, definitely. My concern with that out of the box would be latency. Given that you're doing VIO somewhere else and sending it back to the headset, typically poses need to be generated fast enough to where it's typically has to be done on board, at least in my experience with this stuff.
Yeah, so actually, Bryan, that's the research we are doing right now, is to see what sort of latency compensation techniques we need on board, and how to split the computation so that you can do part of it, just a little bit of it on the headset, but most of it away. And actually working with the Intel folks. So Javier gave a talk here. Javier, you should talk about your work. The talk that.
Yeah. So I'm a wireless guy, and I've been working on wireless time-sensitive networks. So basically, our focus is in, enabling deterministic Wi-Fi, which is, something that is, we're trying to debunk that with the right tools, and those tools are coming. You can actually make Wi-Fi quite deterministic. We have some results, and some of the things we're exploring is, if you have these capabilities available, can you actually enable use cases that were out of reach before? And one of the use cases could be, for instance, this. And I think what's interesting about this forum is, we can talk to you and you can tell me, look, these are the actual requirements you need to meet to allow a good quality of experience. And now with that knowledge, we can design, we can tune the network parameters to reach that goal. And there are exciting new features that are coming in Wi-Fi that would significantly reduce the latency and will give you a much higher bandwidth. Just go, if you look at the next generation Wi-Fi 7, now you're going to have access to 320 megahertz in the 6 gigahertz band, which is going to be clean. You can only have with Wi-Fi 6 and beyond. So all those things will be interesting to explore.
Yeah, I think one of the interesting things with that. So we actually just recently went to the MIT Reality Hack in 2022, which was like just actually a month ago. Actually, let me go back to it. So one of the interesting things there was just having so many people in the building. There was around 200 to 300 people, all with different headsets, HoloLens, Magic Leaps, North Stars, Snap Spectacles, things like that. So I'm wondering how that solution would scale to having a large event like that, right?
Yeah.
So is that something that's also being experimented with, or is this sort of more designed for like a few folks in a room kind of thing?
Yeah, this is actually a good question. And this is why partners are critical. And it's this work on wireless time-sensitive network hasn't been done by ourselves only. We are partnering with Cisco. And now what you need in those scenarios is more management of your network. And this is, if you see the new developments in Wi-Fi, Wi-Fi is moving towards a more managed approach, right? And moving to 6 gigahertz with only Wi-Fi 6 and beyond can allow a company like Cisco to coordinate all connections. You can manage all connections by the Cisco access point controller. And in that sense, you can do a much better job in managing the bandwidth and preventing anyone from hoarding the whole thing, right? So I think interesting features are coming, and I think those will be answers for the question you just asked.
Yeah, I mean, that does sound really exciting, because obviously compute's a big challenge. And one of the interesting things about North Star is because it's doesn't have onboard compute. I've just plugged it into like my Quadro RTX 8000 and run some like Unreal MetaHumans on it, which has been really fun, which is something you can't really do with some other headsets without Wi-Fi remoting. So I think that'll definitely be, there's definitely some really exciting things with being able to remote render, remote stream, and things like that I've been keeping up with. Remote VIO is something that's completely new to me, though, so it sounds very exciting.
Yeah. So one of the things, so doing remote VIO requires visibility and the ability to affect the runtime, right? For rendering, you can stay above the runtime. You can do it in the application space. So I think ILLIXR provides the mechanism to experiment with things like that for the first time in an open community. I'm not talking about companies that have their own runtimes. So yeah, we are starting to do that, and yeah, I mean, it's still research right now.
So maybe we can follow up once we have some initial results.
Yeah, so we're
Absolutely.
working with Javier on this using their technology and other things as well. So yeah, we'll definitely keep in touch. Let's see, I have a bunch of questions too, but let me ask Mike. Had his hand up.
Yeah, can you guys hear me?
Yep.
Hey, Brian, I'm J39339 on the forums.
Oh, cool.
Yeah,
Awesome.
I keep asking all these bizarre questions, but I have three. One of them is, and I know you've heard this before, when will you get it down to one cable? The integrator, the driver, and the keypad.
So that's something we're working on now. The only way to do that realistically is with a Thunderbolt 4 cable. And we're working on a new driver board at the moment that includes a USB integrator, which will allow you to have downstream hubs as well. That will essentially be able to switch between either a USB 4 import or a Thunderbolt 4 / USB 4 input, as well as DisplayPort plus USB 3.2. So the advantage, there are multiple advantages to something like that, but the blockers right now for something, for just doing that. Now, of course, there's the chip shortage, which has definitely thrown a wrench in a lot of things, but also the fact that not many folks have a Thunderbolt 4 capable computer. In fact, most of them that I know of are actually MacBooks, which is something that I would love to support. I actually really love my M1 Mac, but there's definitely a few blockers on the Thunderbolt side of things, but it is something we're moving towards. But for most folks, it will likely still be a 2-cable solution, just given that standards like Virtual Link really aren't being pushed forward by larger folks in the industry right now.
Okay, no, I mean, at least you guys are going in the right direction, because I'm like, it looks like a monstrosity. I actually have 3 and driving me nuts.
Yeah, so our current system actually just uses 2 cables. Let me just try and get that over here. So, you know, I mean, it does look fun, but if you route them properly through the side channels of the headset and then around the back, you'll be able to have a pretty comfortable experience. Now, the 2 cables is likely what most folks will end up having to use, though, just because there are some limitations with, you know, carrying power over DisplayPort, stuff like that.
Yeah, no, I'm cool with that. I just wanted to make sure we were going down in that direction. And
absolutely.
The other 2 that I have, one is I've been kind of like messing with or talking with Christ, the guy that's on the right, Moses, that's right. I've been talking with him and Luxanis, and I got the 4-port or 4-camera version of their sample, and I'm trying to integrate that and I created my own mount and I put it on the existing North Star. But now I'm trying to figure out, are we ever going to get it down to just 2 cameras? Because Moses has been teasing me saying, well, I can do hand slam and I can do regular slam, and we won't need 4 cameras or 3 cameras.
Yeah, I think there's definitely advantages to having more cameras, but ideally, with more work, we'll be able to get it down to just 2. I think the main thing with North Star is going to be able to keep it user configurable. One of the things that I think is really valuable is having a RGB camera in addition to the cameras used for SLAM tracking, just for being able to shoot little videos of being able to use the headset. Because even beyond the lower level stuff, which we're discussing in this meeting, most AR, XR stuff gets traction right now by being shared on social media. And having a really easy way to do that is important, to me at least. And I think for a lot of people who would be looking to use North Star as a development platform for interaction, which is sort of the main goal of it, there's obviously a lot of lower level hardware stuff that needs to be resolved and figured out. But I think there's definitely an advantage right now to having more than 2 cameras.
Okay, and you guys you have been talking about the latency, and that was my last question. Was Moses has been, very unhappy with some of the latency he's discovered, and he's trying to make it quicker. Do you know of any way to get that down, rather other than going through the Mirrored X?
Not off the top of my head, I wouldn't be able to give you a proper here's the 5 steps to lower the latency kind of solution. This is something we'll probably have to work with LXRnest over time on. Seems like a bit of a larger project.
Okay, cool. Well, I appreciate it. Thanks for the update.
Of course. Yeah, in the ILLIXR work, we've done a lot of work to deal with the latency issue. So it's not just an issue of running the actual SLAM processing faster, but there's a lot of configurations and how it connects with the rest of the system and so on that comes to bear here. You can compensate for some of the latency, but can't for others. And so, yeah.
Yeah, that's why I was wondering, because the more cameras we put on, it's a higher bandwidth, which means then you need the Thunderbolt 4 or some interface either that we currently have that's top of the line or yet to be developed that can handle the throughput.
Yeah. And one of the problems with that space, because we were looking at I believe it was called an Optiplex connection at some point, and those cables ended up just costing $90 a piece, which obviously is not ideal for something we're trying to keep relatively low cost. I'll put it this way: there's a reason the Magic Leap and the HoloLens are so expensive.
Yeah, I know. I was just hoping that magically you could figure something out.
Right. Yeah. I'll just bend the rules of physics.
Okay, cool. Thank you.
Yeah.
Okay, Mateo.
Hello. Can you hear and see me?
Yep. Hey, Mateo.
No. Hello. I've been working on Monero with the SLAM integration and all of that, and have been dealing a bit with the sensors configuration and the thing you're describing. It is quite delicate, like the configurations you need to have. So that's I can relate to that definitely. Something that caught my eye was that you are using, if I understood correctly, a sensor called OV92828. It seems it's 120 hertz sensors and 720p.
Yes.
Why so high the resolution and refresh rate?
Essentially, it was because we could, and found it really we didn't want to be limited by the hardware, given that we were spending for us what was a considerable amount of money on it, because we can always downsample it later on, right? So if we don't want to use the full resolution or full frame rate of the sensor, we don't have to. But we also didn't want to be limited by our sensor can only go 30 frames, and we actually found that we need more. The kits we currently bought were for evaluation purposes, and there's no better way to evaluate hardware than by having the best hardware.
So it is likely that you use a cheaper one in the end product?
Yeah.
Okay.
Once we get to something where we actually want to start distributing this to to a lot of folks, we'll probably have a fully built camera system that covers extrinsic calibration and intrinsic calibration in the factory. That way end users won't have to do this, but it'll also probably use cheaper camera systems as well, similar to how the Luxonis OAK-D Lite is currently configured, but still it's still being decided on based on supply chain and what's actually available.
I see. So most of the headsets I've been looking at are using an OV7251, which is a 640 by 480 camera at 30 FPS and monochrome. So you definitely have room to pump it up. Furthermore, we were using the RealSense D455, and it was interesting to have while using that low resolution, low frequency might have some issues. For example, in Basalt or in most of the systems, it's cool to know that you can crank it up a bit if your SLAM system is able to run fast. Like for example, with Basalt, that was the case, and we were able to basically duplicate the resolution and the frequency. And that was kind of like that is kind of like a trade-off you can do if you don't have like a super polished SLAM system. Basically, just crank up the samples. So
yeah, and I think that's one of the things we wanted to enable was like, okay, we like at the time there was like a few there was like Orb Slam. At the time we actually ordered these cameras, like Orb Slam was there. There was like the Chimera had just come out, which was really exciting. And we're like, okay, we need to get something to start building our own system. And this is sort of what we decided to evaluate. And then if this works, we can always go down from there, downsample it without having to buy more hardware. But one of the things Luxonis found as well is like most of their customers, because the original Luxonis cameras did have an OV9282 in them, and they're like, oh, hey, we're actually running them at half the resolution anyway, just to make it easier to run on the Myriad. So when they came out with like the OAK-D Lite sensor, which was their more affordable version, they switched the OV, I believe the same ones you were just mentioning, the 7251s. So there's definitely room to swap cameras out and do some more testing there.
Okay, that sounds good. And related, you also mentioned you're basically testing different camera configurations and extrinsics and lenses and all of that. Do you have like something to share about that, or is it still very early in the process?
It's still pretty early, right? Most of the stuff we're doing for North Star right now is all volunteer driven, so we haven't had too much time to do proper benchmarking because none of us, aside from Moses, of course, work on this full time. So, and even Moses has been doing other projects at the moment. So it's definitely still a work in progress. But I think we've narrowed it down pretty well to the, what I'm trying to say is that I think the configuration we've sort of settled on with the evaluation kit that we've got will work well. So that's sort of where we're at the moment, but of course we do need to do proper benchmarking, which is where I am hopeful we can work with ILLIXR on that.
I see. Which basically you will just test a bunch of SLAM systems and see how they. Okay. Do you have like a mockup or something to capture ground truth data for?
So that's actually a great question. And we've been using Blender a lot for capturing ground truth data for the headset for multiple purposes. We've used it for optical calibration to make sure that the polynomial distortions we're using for distorting the actual optics are actually working properly and what we expect, even outside of a real world use case, especially because in the real world, there are so many things you can't control, right? Maybe the lens is like a little bit out from where we designed it, or maybe the screen's like a little bit pivoted or not in the system all the way, or it's at like a slight angle or something. So being able to do ground truth virtual work for us is sort of the way forward, at least in our mind, for being a small organization that doesn't have a ton of resources. So And this is something that a company called Arcturus is actually doing quite a lot of. So that was founded by a few folks who came out of Occipital. And they've been essentially building virtual ground truth setups to train their SLAM algorithms on in game engines, which is really cool because then you know exactly down to like the millimeter where your camera is. So you can be like, oh, you know, it's failing here. Let's figure out why, and then we can adapt it. So I think that really is, especially for this kind of use case, something that would be incredibly valuable.
I see. So in general, the thing that would bother me there is the replicating the camera setup in Blender, but you say it is definitely possible.
Oh yeah,
Being that Arcturus is doing, okay, that's good to know. Okay, thank you.
of course.
So just to follow up on the question about camera resolution and frequency, is there a trade-off here of settling for lower FPS and lower resolution cameras, but instead of 2, actually have 4, like most commercial headsets do these days?
Yeah, I think it depends on the algorithm generally, and I don't have any solid benchmark numbers to give you, but it really depends on what you want to use the cameras for, right? For hand tracking, you're going to want higher frame rate generally. So if you want to use the same cameras for both hand tracking and for SLAM, you know, higher frame rate is definitely helpful there. And you can still sample the camera at 30 frames per second for your SLAM algorithm. But as far as using more cameras, that's definitely useful for SLAM, right? The more landmarks you have, the better. And using a quad camera rig or something like that, obviously Facebook thinks it's valuable, and they're probably, you know, I think they only have like 20,000 people who work for them, so they probably know something that I don't. But you know, it's also more expensive to use more cameras. So it's sort of a trade-off. Is like if we can get it working with just 2 cameras, that's going to be really exciting for us because it does lower the cost of the overall headset. But if we need to scale to 4, we definitely can do that. I think right now that's still something that's being discovered or figured out.
Gotcha. What about depth cameras?
Absolutely. So depth is really interesting. I haven't seen too many papers specifically using depth for SLAM, typically because depth cameras don't have as wide a field of view as is necessary for SLAM algorithms. Typically, depth cameras are around the 60-degree field of view. And that's just off the top of my head. I could be incorrect on that. But it's going to be, at least in my experience, very difficult to find a depth camera that can do 120 hertz. One of the really, or not 120 hertz, 120-degree field of view. One of the interesting things about depth AI is that you can do stereo depth, which actually works really, really well for this kind of stuff. So that's sort of what we're leaning towards instead of an active depth sensor, even though active depth sensors will be more accurate in a lot of cases.
Gotcha. And then one more question about the sensors. So you didn't talk about IMUs, which SLAM is definitely going to need. So are there any on board? And if so, which ones?
Yes. So the Depth AI platform right now has BNO 85, I believe is the name of that sensor. It's one of the best ones, at least from what folks have told me. So I believe it can sample at 1,000 hertz, but that is I'm just recalling that, and that could be incorrect, but that's at least what I recall. So you're definitely going to need IMUs for it. Doing solely visual SLAM is definitely going to be tricky, right? Because we've already been talking about how visually the cameras are only sampled at around 30 hertz for most algorithms, and then everything else is filled in with the inertial measurement unit, because ideally you can't move too far between those individual frames. And if you did, there would probably be something wrong. So yeah, there is an IMU on it. We are that was definitely a requirement.
Gotcha.
So couple of things, yeah. So we've started to use depth a lot because we've been doing work on reconstruction.
Mhm.
So yeah, we'd be interested to hear if you decide to support those as well. That'd be pretty cool for us.
Absolutely.
We do have trouble with a lot of the depth cameras, various issues. We don't have to go into those here. But going back to your question your comments about still trying to figure out where you're going to place the cameras and the headset, etc. So Bryan, there might be actually an interesting collaboration possibility here that is sort of a little bit of an out of the box thing. But I think I mentioned to you recently that we started to talk with our industrial design folks, and they do quite a bit of work on headsets and so on. So they might be interested in student projects if you want to think about that. I don't
Absolutely.
know. Yeah, so this is part of what they do, right? Is to figure out how to factor in human factors and so on in design of these sorts of things. So yeah, if you're interested, I can put you in touch with the folks there.
That would be very exciting. We're always looking for more contributors. And that could be just a really fun project to do as well. I think it's been interesting because I recently watched Alex Kipman's talk on the HoloLens too. And he was like, oh yeah, Microsoft just scanned 1,000 humans of all different kinds and used all that data to make the most ergonomic headgear. And I think he, during the HoloLens presentation, he's like, oh yeah, it's 200% more comfortable. I'm like, how do you even measure that? But it's definitely, I think the more design work that can be done on this kind of project, even outside of just like optimal camera position and stuff, but also like, what's actually comfortable for folks.
Right, yeah.
It would be
of
really
course,
exciting. So
yeah. So yeah, okay, I can put you in touch with them. And let's see about the rest of it, right? So I didn't quite catch actually the Luxonis cameras that you're looking at. Can you just be more specific about
sure.
what is it that it's providing you, right? What exactly are they?
So the general thing that's providing us right now is the ability to have 3 cameras that are synced, and then also have the ability to, if needed, run them through an AI preprocessor. So there are a lot of really cool things you can do with depth AI, including object recognition on board, and of course, stereo depth. The individual camera sensors we're using are the OV9 282s for the monochrome cameras, which are going to be, there's 2 of those on either side. And then for the color camera in the middle is actually an OV9 782. So the interesting thing there is that it's the same center dimensions for each one, which could help with things down the line. We just thought that would be a good call, given that we wanted to have all 3 be global shutter. And when we were looking at options for that, we were like, oh, if we just use the same sensor size for each one, that could have some potential use cases down the road for making things like reconstruction easier. The other main benefit we get from Luxonis is just having access to a wider pool of OpenCV developers. So more folks are using the Depth AI platform than would be using a custom one we built from scratch from North Star. This also means that we don't have to worry too much about the firmware or making sure the device actually turns on every single time you plug it in, because that was an issue we had with some of the other cameras we worked with in the past. And it's just been really pleasant to work with, I think. So for us, there's it's definitely been nice to not have to worry too much about like color grading each one of the camera sensors and stuff. So having that work be done by Luxonis has definitely been a benefit for our project.
Right. So yeah, so I'm trying to understand, what exactly you're going to be using and making available right, immediately. So you said it has AI on board to do object understanding, its recognition, etc. but that's not something that you seem to be concerned with right now. Is that right? Like, where's all that on your?
It's something that we want people to be able to leverage. So in general, if we're going to be having folks buy a product from us, we want it to be the best we can make it and be able to run, like, given that it's programmable, you can run many different kinds of algorithms on it. You can even run the latest CREF stereo paper, which has like incredible stereo disparity depth with it directly on board the Myriad. So there's, in general, we think that having a ability to offload some of the operations from a smaller computer like this integrated AMD system will provide some benefits. We don't precisely know what they are yet, given that we do know that we won't be able to do full SLAM tracking on board the Myriad right now, based on my conversations with Luxonis and some other folks who are more deeply familiar with that chip. So in general, we wanted to have the option to be able to offload certain operations onto the Myriad and then also work with the reliability of that hardware.
So yeah, so as far as I know, so there's a lot of excitement about using neural networks for reconstruction, et cetera, right? Lots and lots and lots of work, but they're still not down to the real time.
Oh, absolutely.
Right.
Yeah,
So Myriad is essentially Intel's Movidius chip, right? And so I'm still not understanding, what are the algorithms that are being run to actually do the pose estimation and so on.
Yeah, and right now we're still relying on things like Basalt or OrbSlam or some of the projects that Matteo mentioned.
But then where are those running? So those
will be running on the host computer. Right now we're not running too much on the Myriad itself for SLAM.
Right. Okay.
That's something we want to look into down the line once we have a proper SLAM solution running. One of the issues right now with running SLAM directly on a Myriad is that you're pretty constrained in terms of bandwidth and memory limitations. So,
but not just so maybe so I don't so Myriad is, so it has Intel's Movidius architecture, and then does it have more general purpose processing also, like
it has a vector processor.
Okay, but is it like powerful enough? I mean, I'm just curious, what are the tracking algorithms that you plan to run on this down the road?
Yeah, so right now we're looking at a few. Spectacular AI's HIB VIO solution. They've actually got a closed source SDK currently that runs directly on Luxonis systems. Of course, the computing for that is done on the host computer rather than on the Depth AI system itself or on the Movidius. I think one of the things that would be really interesting to us to run on the Movidius right now, at least, would be feature tracking. And that's something that they've provided some examples for already, where essentially you can offset, and this is sort of how the T265 from Intel works, because that had an older version, I believe the Myriad 2 instead of the Myriad X on board, which they were doing full SLAM tracking and feature detection on. I think for us, given that we don't have that kind of resources and the ideal situation for us right now would be to have the Myriad X do feature detection and then send that over to our SLAM algorithm. We're not sure what that will look like yet because it's still very early on, and it's likely that we'll be using research and work from other groups rather than developing a full SLAM algorithm ourselves, just given the small size of our organization.
Right. Yeah.
So essentially, we just wanted to have the option there, and the Depth AI platform does provide some just really nice benefits, just in terms of having the cameras set up and having them work every time and having them initialize properly and everything. So,
Yeah, so that I get, and then so I was the thing I was trying to understand was how far they have reached for the actual tracking algorithms. But based on what you're saying, they're basically using your standard, I'd say standard in quotes, computer vision based classical, I guess, algorithms on a regular host computer. That's what it is at the moment.
Yeah, that's correct.
Yeah.
It's likely that the next generation Myriad, which will have an onboard ARM processor as well, will be able to do much, much more than the current system. But that's something that's not coming out until much further down the road.
Yeah. Okay. Cool. Yeah. So that's another thing that it would be interesting to see how we can hook in things like that with ILLIXR, when we have the implementations, because the whole goal of ILLIXR is to do this kind of modular, swap in, swap out of components so that benchmarking becomes easier and so on.
Yeah.
Okay, great. So oh wow, we are at the top of the hour almost. Did you have more slides that you wanted to?
Not too much. So we do have like a little list of our contributors here, which I always like to have. If you guys haven't joined our Discord server yet, please do. You can get there from our docs site, which is docs.projectnorthstar.org. Also, just have a little slide here for saying thanks to a few folks who have been incredibly helpful to us, including Noah Zirkin, who's without his work, Northstar wouldn't exist, at least in the same way it does today. Collabora for not only being super helpful for us getting the initial Linux support going, but also for hiring a few people from the Northstar Discord. That's been incredibly exciting to see folks sort of grow and now have careers in XR. Thanks to ILLIXR, of course, for providing us with hardware that we otherwise would not be able to get. And then, of course, to ILLIXR for inviting me to speak here and continuing to support the Northstar project. You guys are great.
Well, likewise, you too. Thank you for all your help. And, we were able to show ILLIXR on a headset only because of you. So
that's excellent. Very, very glad to hear that.
Yeah. Let's see. I have some other questions as well, but we are at the top of the hour. So I don't know do you have a couple more minutes, Bryan? Just in case.
I actually have to head out to another meeting at the moment. But feel free to drop them on Discord, email Bryan@projectnorthstar.org. So I'll drop that in the chat real quickly.
Okay. Thank you so much Thank you so much for joining us. And this was great. And we look forward to more collaborative work.
Thank you.
Yeah.
And then, as well.
Yeah. And then for the rest, so we are going to be skipping the meeting. We won't have a meeting next week because of travel and so on. We'll join again the week after. So look out for the announcements. All right.
Okay. Thank you.
Bye, everyone.
Thank you.